Hi, welcome back to my workshop. This is a 6-month project where I wanted to design and build my own 3D printer from parts that I had lying around the workshop. These came from a CNC that I dismantled and also an old trunksy 3D printer. So I had some linear rails, I had plenty of stepper motors and lots of 2020 extrusion. Unfortunately, they were all kind of random lengths. I did some research and I knew that I didn't want to make a bed slinger. I'd already got enders and other bed slingers, and I wanted to make a Corexy system. My research took me to the Rat Rig Vcore Pro 1.3 files that were freely available, and they also had step files, so if I needed to I could modify them. That is the motion system that goes in the top corner that the belts run on. This works very nicely alongside the EVA 2.4 hot end system. This provides a mounting for the extruder, various mounts for different hot ends, and the cooling ducts. This runs on a linear rail that goes left and right. That goes on the gantry on the top, and the belts move this around. The advantage of a Corexy over a bed slinger, it has a lot less weight to move around, so you can print faster and you get a lot less ringing that you would get from the heavy beds. So I'd found the files that I wanted to do, and I had plenty of parts. I ordered a metal cut-off disc so that I could use my miter saw to cut the lengths that I wanted to. I had a few linear rails. I ordered a few more from Amazon based on the lengths of the 2020 that I'd got. So it was a bit of a mismatch of parts, but it should be okay. I was going to use the old board that I got out of my Anycubic Chiron, but I wasn't really comfortable with Clipper. I wasn't sure that I wanted to struggle with an old board and decided that I needed a new board. I sold a few of the retro computers that I've restored on the channel previously. They went to good homes, people that were actually going to use them, and I used that money to buy some more parts for the printer. So I got a big tree octopus and a couple of drivers. I ordered a screen to go with it, a nice touch screen, a few other bits and bobs, lots of nuts and bolts and various things like that. I then started to make a better design in my CAD software so that I knew what I wanted to make, and it was all coming together nicely. I did find that I was having lots of problems keeping my cuts straight and square, and it was making the frame a little bit wonky. So very quickly I decided that I needed to order some actual parts cut. This also was influenced because the parts that I got for the Vcore Pro needed 2040, not 2020. So these parts along the top and the bottom, I ordered those pre-cut and pre-tapped from Ooze Nest. Same with the parts that connect the top and bottom together. And I also ordered the parts that I needed for the motion system, so the belts and the pulleys and the idlers. I gradually started to put this together, but it had a lot of 3D printed parts that was holding things together, and especially on the bed. And they were flexing, they were only PLA. I wasn't very happy with that. But I did manage to get it printing. Clipper was really, really nice to use. It didn't take me long, especially with the printer default that I got from Big Tree on their GitHub. So I was able to get a basic system working, and I did get a first print using that trunksy bed. It wasn't heated, but it was okay. I was very, very happy with the first prints that I got. Eventually a clone Prusa bed arrived that I ordered from AliExpress, and I got that into the system. The first prints didn't look very good. This was because I didn't understand how the PID tuning was working, and the default was using what's called water PID, which was a wave, and that wave meant that the new bed was going up and down, and the prints had very apparent wavy lines in them. I then reconfigured Clipper to use normal PID rather than water, and that fixed those wavy problems on the Z. It was printing very, very nicely, and I was very happy with my progress. The next parts that I wanted to do was to replace a lot of those 3D printed parts with metal cut parts. I do have a CNC, so I decided to look into this, and I ordered some 3mm flat aluminium sheets, and I also ordered a 3mm angled corner piece to replace the parts that I was using on the Z to hold the bed in place. I noticed that they were flexing quite a lot side to side. They were also very close to the heated bed, so I didn't want to have plastic parts close to the bed that was going to get quite hot. I didn't know how hot they would get. I did try printing in ASA, but I was having lots of problems with them warping. So that's why I went with these aluminium corner brackets, and I worked out how to make a jig on the CNC, and I could cut the pieces that I want. To go along with this, I ordered some more parts from Ooze Nest. So I then eventually replaced all of those 2020s that I had left over from the old printers. I did want to use a lot of the old parts. It was proving very difficult to make a nice, square, strong frame, especially without 3D printed parts. My next big improvement was based on the blind joints. So instead of using 3D printed parts and brackets to hold things together, I would cut holes in the 2020 that allowed you to put an Allen key through, and then you could use what's called a blind joint with screws on the inside. So that made the frame a lot easier to assemble and look a lot neater, and had far less 3D printed parts. So the first version, I'd done away with as many PLA printed parts as I could. We got an all metal frame with lots of aluminium parts that I cut. I cut custom parts to mount the steppers on, so they would go into the corner as close as possible. And I also cut aluminium parts that would go on the gantry to hold the gantry parts to the linear rails. This was increasing the strength and the overall durability of the printer. As time went, I was upgrading lots more parts on this, and the print quality was just getting better and better, and eventually it took over as my favourite printer. It literally became my daily driver. I even liked it more than the Prusa Mark III that I've got, and that is an amazing printer. The print quality was good, the print speeds were good, it was very easy to use, it was reliable, and I was very, very happy with it. It was at this point that I knew that I wanted to make a second one. That's what you see here. This is the second build, and that's what we're going to build today. So we're going to look at some of the CNC work that I did. We'll quickly go over some of the techniques that I used to build the frame, how the frame went together. The tricky parts are putting the idlers into the motion system. Some of the parts that I printed were in Prusa polycarbonate carbon fiber. So they're very, very strong, they're very light, they will coat with high temperatures, and they look gorgeous. I was very happy with that. Big shout out to Filament Frenzy, who decided to go halves with me because I knew I didn't need that full spool, and it's £60 for a spool. So now that I finished, I will be sending him the rest of that filament. On this one, I went with the EVA 3 hot end system. It's their new system, it's a big improvement over the first one. But I still have the same setup. It's basically the same printer as the first one. It was just a lot easier to make. All my parts arrived, and it was the Jubilee bank holiday, so I had 4 days to do this, and I recorded everything. Here we have the second printer. It's like 95% complete. It's actually working. I've done prints on it, but the parts that I've got left to do are mounting the screen, the power supply cover, and the position of the Pi. As you can see, I do have some aluminium parts that I purchased. They came from Amazon, and they included the T-nuts, and it just made sense to buy those. They were very, very cheap. But I did machine my own mounts for the stepper motors, and that's mainly because they fit in the corner. Same goes for the lower corner brackets, and the reason that I machine those myself is so that they will have this part missing, so that they will sit either side of this part. Another part that I machined is this cross support for the bed. That's cut from an angled piece of aluminium. So we had to cut the top and the side separately. We'll look at that shortly. And the last part that I cut is this mount so that the gantry fits onto the linear rails. So let's quickly have a look at some of the machining I did on my Workbee CNC. The first part of the CNC work is to stick the material to the wasteboard. So I use blue tape. We stick it to the back of the aluminium after it's been degreased, and then I stick the blue tape down to the wasteboard. Using super glue, we can join the blue tape to the blue tape, and that material will stay in place. It will not budge even after the CNC is digging into it. Then I just put some weight on the top and just let the glue dry up. Then we do a bed probe to get the surface of the bed, and we set the Z equals 0 to the top of our material. We fit on the dust guard, attach it to the hoover, switch it on, and we are ready to go. So we have our machine coordinate set, we've got our Z equals 0 set, and we've got a mapped surface, we can start the job. The files are made in VCAD Pro, and then I just set them running and leave it. This is obviously sped up. You have to be very careful with how fast that you are cutting, because you don't want to break the bits, and these bits that I'm using are very, very small. So we'll leave that going. It's going to cut both of the stepper mounts, and then we just have to pick the parts out. Next, we are going to do the holes for the blind joints. I cut a channel into the wasteboard and 3D printed some brackets. So that will hold the 2020 in the same place every single time. We can slide it in and slide it out. Then we line up the cutting bit to be in the center of that 2020, and we position it so that it's in the correct place to start the job. Once we've got it lined up, we can just run the job and it will cut 2 holes in the end of it, and they are slightly elongated so that I don't have to be so precise. Once we've cut those 2 holes, we take the 2020 out, turn it 90 degrees, put it back in and cut the next 2 holes. And that was how I did those holes for the blind joints. We just repeated this process over and over, and we got the holes in the same spot every time. The next job is to cut the cross support for the bed, and I used that 90-degree angle 3mm aluminium. I machined a groove into the wasteboard so that it would fit in perfectly. Then we secure that down with some double-sided tape. Step 1 is to set the machine at 0, so I slowly nudge it into the correct place. Then we set the work surface equals 0, put the dust guard back on and start the job running. This one doesn't take very long, there's only very small details. Once that is finished, we take the piece out, we flip it so that we've got another flat surface, and we do the second side of the cuts. I did take quite a while to get this lined up so that it would cut perfectly with that groove, and it was a little bit tricky, but now that it's set up I can do it pretty much every time. So now that the CNCing was done, that was a whole day by the way, we can start to assemble the frame. As you can see here, we've got the holes for the blind joints that I machined, and the first part of the frame is these end pieces. So we have a 2040 at the top and bottom, 2020s on the sides and in the middle. So we will fit all that together. We will install the linear rails on these upper parts and get the stepper motor in with the cross beam. We'll do one side first, then we will do the other side, and after that it's just a matter of joining the 2 sides together with these central 2040 extrusions. After all that is done, we should have an actual frame that's built and ready for the next part. The first steps to building the frame is preparation. Now I've checked and marked all the extrusions to show how many T-nuts I need on each side. Then we slide them all in, double check again before we start to put the frame together. As we can see with the blind joints, it's very easy and the 4 parts just slide together. I keep everything flat on the worktop, start with the corner brackets on the longer 2020 extrusions. I'm not over tightening at the start, it's just enough to keep it together. I adjust the bolts in the blind joints and on the top brackets a little bit at a time until it feels secure. I'm always using the corner brace to check everything is square until everything is nice and tight. The next step is to insert the extrusions that the linear rails will sit on. We need to make sure that the T-nuts are facing in the correct way on the inside. I used some 3D printed spacers to roughly position them and then clamp the top and bottom together while I tighten the lower bolts on the blind joints. Then we double check with the spacers one more time by sliding them up and down. This should move freely without binding. Flip the frame over and fit the T-style brackets to secure everything together. Now we use the calipers to position the extrusion and make sure that they are 98mm from the left and right sides. Gradually tighten all the bolts on the T-brackets until everything is secure. Before I install the linear rails, I have to degrease all the junk that protects them in shipping. I use WD-40 degreaser, give them a good spray, clean all the ball bearings, wipe down and then let it dry. Next I use white lithium spray into the holes on the back side of the rails so that they coat all the ball bearings. and then check that none are missing. When this moves nice and freely, they can be screwed to the 2 extrusions that we inserted all those T-nuts onto. To align all of the T-nuts, just put the rail next to them and position them, skipping every other hole. This particular rail used M3 cap heads, and I loosely screwed everything in before using a 3D printed guide to actually make sure the rails are central to the extrusions. The last step is to just fit the NEMA 17 bracket for the stepper with the lead screw. Now we are going to set up the angled support I machined and make sure everything is moving freely. I loosen one of the rails so I can make it parallel to the other rail, using some spacers to hold the cross support in place while I tighten the bolts holding it to the rails, then one by one tighten the bolts on the rail as I move the cross support up and down. It should move freely without binding. Then I installed the stepper with the lead screw into the bracket and secure the Acme nut with a backlash spring to the cross support, not forgetting to adjust the position of the stepper so the lead screw is straight. Test this by turning the lead screw and moving the support bracket up and down the frame. It should move nice and freely. Repeat this for the other end of the frame and we are ready to move on. Now we are going to connect the 2 ends together using 2040 extrusions. Just like before, we prep the T-nuts, installing them where we need to, and we also install the linear rails. I didn't show installing them this time, just like before. I lay the end flat on the worktop, then I can slide the linear rails up until they reach the top corner brackets. We secure them to the corner brackets and the blind joints on the side. After that, I install the stepper mounts just below those into the corners. Again, using the corner brace to keep everything square and slightly tighten all the bolts in. Then we slide the bottom 2040 into place and install the lower corner brackets that I machined. We just take our time to gradually tighten everything, constantly checking that things are square as we go. Next, we can slide the other end of the frame onto the 2040 we just installed. Check the bolts are in far enough on the ends of the 2040, otherwise you'll have lots of friction as you slide it down. Work your way around all the bolts, slowly tighten everything up. The longer you take at this point, the better the frame will be, so do not rush it. At the end of this, we will have an assembled frame with the Z-linear rails, lead screw with stepper motors, and the support for the beds, as well as the linear rails for the gantry. Now our frame is assembled, we can start to add in some more of the parts. And the next stage is the motion system on the top. This came from the Rat Rig Vcore Pro 1.3. So here you can see the corner piece, and then there is a piece on either end of the gantry. This is where all the belts run to go to the hot end system. So I will quickly go over assembling of these parts, putting the belts and pulleys in the right place with the spacers before we put it into the actual printer itself. I think this is the most fiddly part of the build. You can see the 4 parts from the Vcore Pro 1.3 motion system. 2 corner parts, 2 gantry parts. The gantry parts are marked left and right, and one has the spot for the X access switch to hit. The correct pulley parts are already in place, but they are not spaced correctly, so that is the next job. I will start with one of the corner brackets, and as you can see, I have 2 toothed pulleys in place, but they need spacers installed. First is a larger precision washer, and that is followed with a precision shim. And the shim is sized so it only touches the bearings of the pulley. Then we have a toothed pulley, another shim, a second pulley, another shim, and then at last we have a washer. These last 2 are a bit tricky the first time you try this, but I had a good way to do it from the first printer build. I then used a nylock nut to secure everything in place. I take my time to get a perfect amount of tension so the nut and bolt does not move up or down, but the pulleys can spin and move freely. I then use a little bit of PTFE just to help with that. The 2 ends of gantry are just about the same, but we only have 1 pulley on each side, and then the gap is made up with 2 larger spacers. It's important to get the smooth pulley and the toothed pulley on the correct side, with 1 closer to the top, 1 closer to the bottom. Depending on the left and right, this is different, so you have to pay attention to that. And then again, they are tightened with a nylock nut so that they will move freely with no up and down play. This is the EVA 3 system that I printed. The silver parts are PETG and the darker grey parts are polycarbonate carbon fibre. I have a Dragonfly hot end in there and that incredibly stupid cooling duct on the back with that big loud fan. I love it. Installing the corner brackets for the motion system is also easy as long as we place those T-nuts into the frame at the very start. Luckily for me, I did this, so they just screw into place. Do it a bit by bit so the printer part fits snugly on both of the extrusions in the corner. We have two NEMA 17 stepper motors to install. These came out of the old Trunksy printer. Fit the tooth gears onto the top first. Make sure one is reversed to the other. Do not tighten grub screws so that we can adjust that later when the belts go in. And these screw into those custom corner brackets that we machined on the CNC for the stepper motors. We take another piece of 2020 extrusion that has a linear rail on the top, again loosely placed on so that we can adjust the position later. We slide on the two gantry pieces on the left and the right, and that just pushes on. The gantry pieces are attached to the linear rails with another metal bracket that I machined, and everything bolts together. This makes it very strong. I loosen off one of the Y linear rails so that we can make sure that both the rails are parallel to each other. We shouldn't have any friction or binding when we move that motion system around and around in a circle. Now we can move on to installing the clone Prusa bed. We've got the cross beams and then the bed, and here we can see the texture plate on the top. Let's go. The next few parts are relatively easy. We start with two 15-15 extrusions that I cut so that they would fit. Make sure to fit 4 T-nuts onto each one. They fit onto those aluminium corner cross supports I machined with an M3 bolt at each end. Nice and easy. Here we see the clone Prusa Mark 52 24 volt bed and Y-frame that I ordered from AliExpress. I made a template to center punch the spots that I need to drill. Then I enlarged the center punch marks with a smaller drill bit and finally drill all the way through with a 3.5mm drill bit and then countersink the ends to take the high spots off. I screw the bed frame to the 15-15 extrusions that we fitted previously with 4 T-nuts and position it closer to the front. Then I place the spacers that came with the bed frame kit on the frame. It's a bit tricky as they can fall off while you're trying to fit the bed on, so you just have to take your time. Then I use countersunk screws to secure the heated bed to the Y-frame, start in the middle and then work the corners followed by the rest. Do it a little bit of time so that you get a nice even level bed. It's not perfectly flat, but the bed mesh can deal with what's left. And then last, I can fit the Prusa textured bed. It just snaps into place with the magnets that are embedded in the heated bed. It'll be interesting to see how well this works compared to an original when we get up to some higher temperatures. Here I am installing the EVA 3 system onto the gantry linear rail. I'm very sorry that I don't have any footage of the EVA being built. It was something that I did a few weeks back. But again, that's quite easy and the instructions on the website are very good. So one part bolts onto the MGN12 carriage with 4 bolts. The EVA fits into that and then there are 2 long bolts that go all the way through. Then we fit that awesome cooling duct onto the back with 2 more bolts. On the side it has a spot for the X end stop, so I put that into place and then I take time to position the linear rail without going too close to the end of the rail, making sure that the end stop activates. Now I can use the alignment tool to secure the rail down to the center of the 2020. I then raise the bed up to check for clearance of the lead screws at the front and back and mark them at the right height. I cut them down to size off camera. You can see the lead screw at the back is going to touch the cooling ducts, so it needs to be shorter. Wow, that was a lot of work. I think that was 3 days that we covered just then. Like the machining was 1 day, building the frame was another, and then doing the motion system was the 3rd day. But by the end of the third day, I was getting pretty tired. I was making quite a few mistakes. So there were some parts that I didn't film. And most of that was testing the old Anycubic board, checking the stepper motors worked and all that kind of stuff. It was quite boring and I didn't film it. I did film the next part though the next day when we did the actual testing with it connected to the printer. So we can look at that. After that, there's lots of testing and tuning and test prints, so still a lot more to come. So I think this is a good point to end this first episode. It's about half an hour, so yeah, I think this is a good point. You made very good progress on this, and I was very happy with how it went. So if this is a printer that you're interested in, please let me know. I could get the details up onto Open Builds, and you could build one for yourself. It's quite flexible in the parts that can be used in there. There's no firm type of board, and the EVAs can use many types of hot end systems, so very flexible. You don't have to use the Prusa bed, you could use anything really, but it's quite easy, and the clone Prusa beds on AliExpress are about £60, or you could buy an original, but I had trouble finding the Y-frame, so you could just buy the heated bed. Anyway, I'm digressing. So thank you for looking at this first part. Like I say, this project is 6 months in the making, and I finally got the time to make it. So most of the parts are already filmed for the second one, so it's just a matter of editing. So it won't be months until you see it. It will be next week, fingers crossed. So thank you for watching. Like and subscribe and all that doodah, and I will see you very soon.